In part 1 of Please Mind the Planet, we looked at how global warming is already a major problem, affecting regions and people all over the world. In part 2, we will examine some of the likely future changes that await us due to continuing climate change. Almost 2,500 scientists volunteered their time, without pay, to create the IPCC Assessment Report 4, released in 2007. These men and women are the co-winners of the Nobel Peace Prize for 2007.
Now, we can't predict exactly what's going to happen, so they came up with a number of scenarios. The scenarios vary depending on what we, as people and our governments, decide to do. There's actually 40 different scenarios that they've looked at. With all these 40 different scenarios, though, the most likely one that the scientists think might happen, given human nature and all, is this one in the middle, the green one, which is called A1b. The number A1 means that we're taking the assumption that the population grows from today's 6 billion plus to about 8.7 billion by the middle of the century, and then drops down to about 7 billion by the end of the century. The B assumes that we're going to actually use a lot of alternative energy technologies, and we'll start moving into wind and solar power. And you can see, first of all, there's arrow bars. Notice how broad that thing is. The scientists don't know exactly where this is going to be, but it's somewhere in that region. The most likely outcome is that we're going to warm up 2.8 degrees, and these degrees are all in centigrade, over the next century, compared to the period of 1980 to 2000. The IPCC has also studied the impact of various temperature ranges. They created this chart, and don't worry, we're not going to walk through the whole chart here. And across the top, you'll see that we have a range of temperatures, and they go from, if we're lucky, 0, all the way up to 5 degrees. And then they talk about, well, what would happen at those ranges to our water supply, to our ecosystems, the biosphere, to our food supply, to the coasts, and to health. Well, let's look at it in terms of water. This map goes back almost 300 years, and it shows what happened to glaciers all around the world. Now, some glaciers advance. The ones that are close to the coast, or what they call tidal glaciers, as the weather warms up, we get more rain, and in the colder places that becomes snow, so some glaciers are actually advancing. And a lot of people who are denying this climate's changing will point to those few glaciers and say, see, look, these glaciers grew. But as you can look here, on average, all the glaciers are shrinking. And what this means in every continent is that our water supply that we use for drinking, but more importantly for agriculture, is diminishing. There's over 1 billion people who will be affected by a shortage of water in the next 30 to 50 years. So what's going to happen when these 1 billion plus people run out of water? They're not just going to stay where they are. In fact, we know what's going to happen. We're seeing it happen right now in Africa. There are water refugees, which is causing a lot of the problems and the hardships in areas like Darfur. These people are not going to stay put when their water runs out, when their food goes away. They're going to start moving. And that's going to create chaos, economic hardships. Another big concern with the warming temperatures, not just the ice on the ground, but also the Arctic. This graphic here shows the normal extent of the Arctic ice at the end of summer. Now, at the end of winter, normally the Arctic sea ice covers 11 million square kilometers. It's a huge area. And during the summer, it starts to shrink. And normally it shrinks to about 7 million kilometers. And as you can see here, it's nice and white. And again, we like white. White reflects sunlight away. It cools the Earth. In fact, white ice reflects 90% of the sun's energy back into space and only absorbs 10%. Open ocean is the reverse. Open ocean absorbs 90% of the sun's energy and only reflects 10% away. This kind of tan color here showed the average end of summer ice extent. So this is the 7 million range here. And this is what it was at the end of 2007. It shrunk down to 4.1 million kilometers. It had never been that small before. And the problem is when it freezes over again in the winter, it's very thin. It's what we call single-year ice or new ice. Multi-year ice that's been there for tens of years is very thick, and thick ice takes a long time to melt away. But very thin ice melts even quicker the next summer. A lot of people are trying to forecast, well, when will we lose it completely? When will the Arctic be gone at the end of summer? Well, the IPCC thought in its assessment report, the last assessment report, that we'd probably lose it totally by 2080, which is probably outside of our lifetime, but not necessarily outside of our kids. However, the National Center for Atmospheric Research in the US in Boulder, Colorado, they recalculated it and said it'll be gone in 2040. That was in 2006. In 2007, they reran their numbers. They think it may be gone in 2012. In just a few short years, the Arctic summer ice will be gone. And all the animals that live on that ice, all the native people that live up there that have the lifestyle predicated on ice, they're going to face drastic changes. And even though 2007 was the smallest aerial extent of the ice, 2008 was the smallest volume of ice. It covered more area, but it was actually thinner. So the ice is getting thinner and smaller, and we're basically losing the Arctic. Look at what will happen to food as climate warms up. For every degree we warm up, we lose 10% of our world's crop production. As the temperature gets hotter, first of all, pollination starts to slow down. And then if it gets hotter yet, the plants stop doing photosynthesis. They stop taking out carbon from the atmosphere, and they actually start emitting it back in. If we warm up 2 degrees, we lose 20% of the food crop. Just a 1 meter sea level rise in places like Bangladesh will destroy half of the rice crop because the salt water will start infesting the lands, so they won't be able to grow rice there. And it takes 1,000 tons of fresh water to grow 1 ton of grain. We're going to have less fresh water. We're losing the Himalayas, the glaciers there. We're losing glaciers in the Rockies. We're losing in the Andes. We're losing in the Alps. We're not going to have as much water. The UN tracks, we lose 18,000 children a day through hunger and related problems. That's 6.5 million kids a year dying of hunger already today. And we were doing a pretty good job of reducing hunger in the world. It used to be in 1970 there was almost 1 billion people that were hungry or dying because of malnutrition. And that started to come down to 800 million by 1996. But then it started climbing again. We're up to 830 by 2003. And now the forecast by the UN is that we'll be up to 1.2 billion by 2025. If we look at what's happening to our biosphere, biodiversity, we used to have rainforests covering 12% of all the land in the world. Today we're down to half that, only 6%. And that's important because the rainforest houses half the plants and the animal species that we have. We're converting 50 million acres a year into carbon, and we're putting that carbon up into the air. Because we're putting more and more carbon dioxide into the air and it's getting into the ocean, it's actually increasing the carbonic acid in the ocean. The carbon dioxide in the air reacts with the ocean water and creates a mild acid called carbonic acid. The ocean's normally fairly alkaline, but now it's becoming more and more acidic. And at certain levels, animals in the ocean can't make shells anymore. Things like coral, but even more worrying, things like plankton. Some planktons, about half the plankton, need to make a shell. They can't, so they're dying. And the planktons are at the bottom of the food chain. We need planktons. Coral, as I mentioned, is also being affected. Now, coral only cover 0.2% of the ocean floor, so it's not like there's a vast extent of it. But they house 1/4 of all the marine species in the coral, and we're losing the coral. 60% could be gone in the next 2 to 4 decades. The current pace of extinction that's happening right now is 1,000 times faster than the historical rates. And that's not just from global warming. That's from a whole bunch of causes, such as our pollution. At the current rate of species loss, 50% of all species will be gone within the next 100 years. We are in the midst of the 6th greatest mass extinction ever happening on the Earth. Now, this is not all because of global warming. There's a lot of other things that are happening. Our overfishing, our pollution, too much nitrogen in the soils that we use for fertilize. The farmland gets run off into the water, which comes into the oceans. So there's a number of different causes. Global warming is a big contributor of this, though. But right now, we're in the midst of a huge mass extinction, as big as the one that happened 65 million years ago when the asteroid took out the dinosaurs. So if we just look at 2 degrees, this is what the IPCC says it means. At 2 degrees, we lose 20% of our food crops just from the heat effect. We put at risk 30% of the species, again, just from the heat effect. We'll actually use more because of other effects. We could raise sea level by 0.5 meter or more. Most of the coral around the world is wiped out. And what's really worrying is at 2 degrees, we start to tip what's called positive feedback. These are things like we lose the Arctic. As we lose the Arctic, more sunlight's going to be absorbed in the water, which means it's going to get warmer, which means we're going to lose more Arctic, which means it's going to get warmer, which means we lose Greenland, which means it's going to get warmer. So that's a feedback loop that just feeds on itself, making it warmer and warmer. And at 2 degrees, 15% of the land will stop absorbing carbon and will start re-emitting it back out. So again, at some point, it won't matter if we don't emit any more carbon. We'll have tipped over, and it's very difficult when something tips to push it back up. It only takes a little bit to tip something, but it takes a lot of work to put it back up again.